Morning, students. Testing if you can hear me and see the screen. Hello. Hey, John Maynard, can you hear me and see the screen? In Alexander.
Yes, sir.
All right, thanks. Well, after a late start, but better late than never. I want us to practice a few of these questions that we can apply the trigonometry of non-right angle triangles, where we have to use sine rule or cosine rule. Just to practice and see, how we apply those. And also, I'd like to do one or two bearings questions. All right, so we're talking about the paper 2 exam. This is on the screen here. This is the May 2024 exam paper up the top there. And this is number in section 2, number 9. Second question number 2, the geometry and trigonometry. This is the topic we're going to look at next after this one that we are on now. Circle theory and circular measures. And part B is a question on the topic that we are currently on in class. Alright. So let's look at it. And the pen is going. Alright. The question says the diagram below shows a quadrilateral PQRS formed by joining two triangles. So we have two triangles. Here and here. Alright. It says PQ and S and QRS. So these are the two triangles. None of them are right angled. So we cannot use Pythagoras' theorem, and we cannot use so-called tower in any of these triangles. We have to use the sine rule or the cosine rule. The first part wants us to find the length QR, which is this length over here. To find that length, we're going to work in this triangle. And what do we have in the triangle? We have the situation for the cosine rule because we have two sides, the angle between them. Remember, to use the sine rule, you must have a side and an angle opposite each other, where you know both of them. In this case, we have two sides and an angle between. So it's cosine rule that we're going to use. So we're going to be using the cosine rule. To find the QS. And in the cosine rule, remember, it starts out like Pythagoras' theorem. So you treat this as if it was an hypotenuse and if that was a 90 degree. Alright? And if it was a right angle triangle, the QR squared would have been equal to this side squared plus that side squared. That's 16 squared plus 18 squared. That's if it was just a right angle triangle and you were finding the hypotenuse. Alright? But then you have to subtract a piece because it is not Pythagoras' theorem. So you have to subtract twice the product of these two pieces, which is the 16 and the 18, and you multiply that by the cosine of the angle between them, as the angle inside here, which is 28. If it was 90, cosine of 90 would be 0, and this part will be gone anyway. And so that's 25 degrees. And instead of putting the square in here, we can actually remove this square, put it on in red, remove this square and square root this instead, and that will give us the QR in one calculation. Alright, and so the QR length will be equal. I'm going to get the calculator and work it out. Let me see it up here. Let me get the calculator. So we're going to write square root. I'll put everything under the square root sign. So it's 16 squared plus 18 squared minus 2 times 16 times 18 times the cosine of 25 degrees, and make sure the calculator is in degrees by looking at the top of the calculator. There's a DEG up the top, means that the calculator is in degrees. And it's telling me that that is 7.61. The question didn't tell us how accurately we should give the answer. So I give it correct to three significant figures. 7.61. So that's 7.61. That's meters, not centimeters, meters. The distances are meters. Meters. And that's the answer for that one. But okay with that? But good with that one so far? But okay?
Yes, sir.
Alright. Then now it wants us to find, that's all I wanted, length of QR. Alright, that's all I wanted. Let's put on the diagram in case we need it. So this side is 7.61. So this is 7.61 meters. That's what we worked out, alright? Let's continue. It says the bearing of P from S is 205 degrees. Now remember now, when you're given a bearing, you always want to take note of the from position. And it's from S. So it's from S to P. We want the bearing. So we want the direction from S to P as a bearing, it is 205 degrees. And we need to show this bearing angle on the diagram in order to do calculations with it. And I want us to calculate the bearing of R from S, that R from S, and the bearing of S from P. S from P. So that's the information we're going to want. Alright? So let's put this bearing angle on the diagram so we can work with it. So it's from S to P. The bearing is 205 degrees. S to P. Let's look at that direction on the diagram now. So this is S, this is P. So the bearing of this direction is 205 degrees. Now how do we get the bearing of that direction? At the from position S, we have to show the north line first. Because like we're facing north, let me put it all the way up here. Show the north line up here first. We didn't put any for us, we're going to put a north line there. And it is that we're going to turn to the right until we're facing P. That's the bearing. So that red angle that I've marked is the bearing. This angle over here. That's the angle that we want. So that whole angle is 205 degrees based on what they have said. Alright, so let's put it in like this. Let's put it in on the diagram. Let me take this out. I'm going to leave the north line in there. And this whole angle around it I'm putting in red is 205 degrees. Now, after you put in that angle of 205 degrees bearing, you want to populate the rest of the diagram with angles that you can know. So for example, since these two parts of that angle are known, what do they add to? They add to 97. That's 72 and 25. They add to 97 degrees. So in between here, we have a total of 97 degrees. And so the remaining angle inside here is 205 minus 97. Hope everybody can see that. Alright? So this angle I'm going to mark it in blue. Because we might need it. The angle inside here is 205 minus 97 degrees. Alright? 205 minus 97. That's 108. It's 108 degrees. And put it inside, you know. Inside is 108 degrees. Now see that angle? It's actually the bearing of this direction down to R from S. Because it is a clockwise angle from the same north line to this line that has a direction out to R. So the bearing of R from S, or the bearing S to R right now, down here, is this 108 degrees. So we can see that on the diagram. That's this bearing angle. S to R, or the bearing of R from S. So if you want it, it is that 108. Let's see if they wanted that bearing angle. Let's see. They want R from S. Yes, that is it. They want from S to R. See? At the from position to R. And based on the diagram, it is that calculation. The 205 that we had minus the sum of these two inside here. That blue angle is the bearing that they want. So subtracting these two, let's show the calculation. 72 and 25. And that works out to be 108 degrees. That's what we are, right? 108. That's the bearing. Everybody good at that calculation? But okay? Students, have to respond. Let me know what's happening. If you don't
Yes, sir.
understand, have to talk. Alright. The next one they want is from P to S. Let's look at it and put on the diagram and see what angle that is. We're going now from P to S. From P to S, we'll work out that angle now. Let's look at the diagram and mark it, the angle that I want. P to S, let me take these off. So this is P. I want the bearing up to S. Let me show you the angle that I want now. So from this up to this. In other words, use a different color for this part. They want the bearing of this direction, P to S. From P to S. Alright, so the bearing is measured at the from position. So at the from position, I'm going to put in a north line that is now parallel to this. Let's put by the north line in the red. So at the P point P, put in the north line. Remember, the north-south lines are the most important lines in bearing. Because the north line is the most important line in bearing. Alright, let me shift this up. Stop here, so we'll get 108, right? And that's the north line here. And the bearing that they want is the bearing this way. This angle. Well, the marker giving me hell over here, guys. I'm not kind of cooperating at all. The bearing that they want is this angle that they want. That's the bearing of this direction right now. From P. That angle we want. Alright? What do we know? Since these two lines are parallel and they are joined down here by this, we have formed a U. We will call a U angles. And those two angles are co-interior in the base of the U. So these two angles that I'm marking on purple, these two, they add up to 180 degrees. They are co-interior angles. They are supplementary. They add up to 180 degrees. And we're trying to find this one. To find that one, we need to know the one up here. Alright? And can we find the one up here? Yes. Because what do we know? Total angle around this point is 360. And we have 205 up to here. Here. We have 205 up to here. And so this remaining piece that we want is 360 minus 205. So that's what I think. Put on the calculator. 360 minus 205. That's 155 degrees. So this angle is 155 degrees right now. 155 degrees. How did we get the 155? It is 360 minus 205. Because total angles around a point is 360. That's how we get the 155. And then the angle inside here now that we want becomes 180 minus this. It becomes 180 minus the 155. That's what that angle is. Right? So it's 180 minus the 155. That's 25 degrees. Right? So that's 25 degrees. That's it. 25 degrees. Because the angle is 25 degrees, the bearing is 0, 25 degrees. The angle is 25 degrees inside here. But expressed as a bearing, it is 0, 25 degrees. So we can leave all this calculation on the page and CSEC will accept it. All these calculations that are placed on the page, CSEC will accept it as a part of your work. It's okay. Right? But I'm going to show this calculation down the bottom. Right? So I'm going to say its bearing angle that I want becomes 180 degrees minus 155 degrees, which is 25 degrees. But because it's bearings I want, you have to put the 0 in front of it. You have to put the 0 in front of it. Because bearings must be written with 3 digits. And that's the answer right there. Nice and easy question. This one is nice and easy. That's 2024. Everybody okay with that? Everybody good? For move on and do another one? Alright, good. Let's go back and do the 2020. Let's do 2023. Let's work our way back. I could do January 2023, but I can just focus on the June papers. Since I have a folder. I close the folder. Did I close the folder? Alright. So let's do 2023. Right here. Okay, that's the one that I want. Let me see. This one. That's what they asked in 2023. And it's number 9. All the way at the back is the Trigs question that we're focusing on doing. Alright, here we go. Here's a bearings question. So the north line here. So that's a bearings question. Alright, let's see what they accept first. Over here is circle theory. Alright, so we're going straight to this question now. Alright, it's a bearings question. So let's see what it says. This question says, as I tell you guys, in recent times, they give you a diagram for every bearings question. In the past, you had to draw a diagram from scratch. But the most recent exams, yes, they are giving you the diagram. So they're helping. It's making it easier for you. Because they present you with the diagram. Now notice in this triangle, they give us 3 sides with no angle. Once you have that, you must use cosine rule to find an angle. Alright? Let's give you that off the bat, because the triangle is not a right angle triangle. So once you only know 3 sides and don't know the angle, you have to use cosine rule to find the angle, one of the angles. Alright, so it says the diagram below shows a triangular field LMP. So the distances are in meters, right? Like a national stadium 100-meter track, and this is just 150 meters. This is 120. This is almost as long as the stadium track, right? And the stadium track is 100 meters. So this look like an area as a little bit larger than a stadium. Alright, but it doesn't matter. I just wanted to put it in perspective. The scale of what we're dealing with. We're not dealing with a triangle on paper, but these are in meters. Right, and so always remember 100 meters is the length of a stadium track. Just remember that one side of a stadium track is 100 meters. So you can start to relate that. So this is 1.5 of the length of the stadium track, the 100 meter stretch. But they run the 100 meters. This is 1.5 that. Alright? And this is almost twice that. That's 180. So put in perspective the size of the field that we're working with. Alright. So it says calculate angle MLP. That's this angle inside here one. MLP. P is the letter in the middle. So it's right here the one. Angle MLP. Let's give it a letter and call it a name. Let's say that this angle is theta or alpha. Let's put it as alpha. I like to put angles inside the triangle as alpha. So I'm going to call it alpha and put it in the diagram as alpha as well. So we can just call the angle alpha. Keep it simpler for us. So we're trying to work out that angle. Now, because that is the angle that you're going to find. You have to treat this side over here like the hypotenuse. Because what am I using the cosine rule, So you treat it as if these are your two sides and your angle between them So remember, cosine rule starts out like Pythagoras' theorem, right? Treating this as if this was a 90-degree angle and as if this side across here was your hypotenuse. Alright? It's very important that how you set it out. Very important. Alright? So I'm going to underline these two as if it was the two sides with an angle between them. And you're making this subject as if that was your hypotenuse. So you start out like how you would start out the cosine rule, where the cosine would start out like Pythagoras' theorem. So if it was a right angle triangle with this as your hypotenuse, you would have had 180 squared equals this side squared plus that side squared, 150 squared plus 120 squared. Remember now, it's not Pythagoras' theorem, so you have to subtract a piece, but you're subtracting twice the product of these two sides, the 150 and the 120 without the square on them, and you cosine the angle between them, but the angle between them, you don't know it, it is alpha. So you have to put the alpha. And you really know trying to find that, or you're actually trying to find the alpha. So we're going to do some transposition now, alright? So bear with me now. We're gonna take this negative something and bring it over this side and make it positive. We're gonna take this 180 squared and bring it over this side and subtract it. That's what we're gonna do. Alright? Let's see. So this side, in fact, I can just copy it across this. I can copy it across to the right side. So we'll copy this over. Copy this. I'm gonna paste it on the right side. Over here. I don't want the minus on it, so I take out the minus. And it becomes equal to, and I'm putting these back. 150 squared plus 120 squared. When this that is over here, it's coming over here and minus. I'm going to subtract 180 squared. I'm not going to work these out yet, I want to do one calculation at the end. So much space you have. See, that's the thing. They give us a small amount of space. So you realize that they don't intend for you to be doing a lot of lines. Right? So the space that they give you to work in is very small, right? What happens next is that this thing is now divided under the right side. Right? Divided under the right side. So I'm going to put in the line, the division line for you. And I'm going to just take this and I divide it under here. So cosine of the angle now is equal to that. But it is the angle that I want, remember. So to get the angle, I'm going to take the inverse cosine over here of that value there. So I can set up like this. I can shift this out. I'm going to put the cosine inverse over this side and put the minus 1 on it as the inverse of all of that. And that's why you have alpha as a subject. Now watch over the video, guys, and see how I did that transposition, because they don't give a lot of space to work on. So you have to be very efficient with the work. And you can just put all of this in the calculator. So you see, with this small amount of space for 3 marks, they don't expect you to be working out these individual values and wasting time. Just do your transposition so you can get your answer with one calculation. It's going to be very accurate. So that angle alpha that they want inside, you can just work it out with the calculator now by putting everything there in the calculator. And that's another reason we have to get one of that type of calculator. That you can type that expression in fully as it is there. So see there, it's cos to the minus 1 of a fraction. On top of the fraction, I have 150 squared plus 120 squared minus 180 squared. And I'm putting that over 2 times 150 times 120. Put in the calculator, I'm getting 82.8 degrees. Alright, and they didn't tell me any level of accuracy, so I'm giving them 3 digits. 82.2 degrees. 82.8 degrees. 82.8 degrees from my calculator. That's the answer. Are they okay with that? But alright? Making sure before we move on. But alright with that calculation? Yeah, it's better. Nobody's answering. I mean, nobody's okay with it.
Yes, sir.
Degrees. Alright, so this angle we know it now, right? It's 82.8 degrees. And we can actually just scribble it in on the diagram since we know it. So we can just write 82.8 degrees on the diagram. That's what it is equal to, right? That angle. We're gonna need it now. I know that we have that angle, but we side opposite to it. We can use sine rule going forward. So for example, if we want to find, only thing we don't know on this triangle are these two angles. So any of those two angles we're trying to find now, we can use sine rule. Right? And that's the only thing that is missing now, those two angles. Right? We know everything else in the triangle. But this is what they want now. Next part now says the bearing of P from L. And remember, when you get that bearing, you must always know the from position. Or when you're drawing a bearing or calculating a bearing, you must always focus on the from position. Everything is done at the from position. So from L to P, this means from L to P, the bearing is 210. So the bearing is at L, at the from position, 210. Let's put the angle on the diagram so we can work out other things, right? They want us to calculate the bearing from L to M. That's what they want, from L to M. But they're giving us this. Put it on the diagram so we can see how it helps us. Don't just work with it blind. Put it on the diagram and you can see how it helps us. So L to P is 210 degrees. Let's put on the diagram. So say L here, say P here. So from L to P, that's this direction, is 210 degrees. What's that bearing? It's all of this angle around here, clockwise up to here. That is the angle that is 210 degrees right now. Because remember, from the north line, you have to face north first and then turn to the right. Right? So it is that angle there that I'm leaving on the screen in red. That is 210 degrees. Let's put it out here. 210 degrees is that angle. Now because inside here, so is 82.8. We can actually work out the angle in here by subtracting. This is a similar calculation to the one that we did earlier. Let's put that down in purple. And that actually now is gonna be the bearing down to L. This angle right here, down to M, sorry. This angle right here is the bearing of this direction now, down to M. The bearing is a direction, you know. It's a direction given as an angle, clockwise from the north direction. That's what bearing is, you know, from one place to another place. That angle there now is a bearing down to M from L in purple. And it's obtained by simply subtracting the 210, or doing the 210 minus 82.8. Right? So we can do it over here right now. 210 minus 82.8. We're getting 127.2, but in bearings they give 3 digits. So I'm gonna put 127. Right? So the bearing in here, the angle that I want in here, that is in purple. I'm gonna just write 127 degrees in there. You understand? Because it's bearings, they don't need the 0.2. I always want after 3 digits. 127 degrees is the bearing of M from L. Let's see if that's what they wanted. I'm sure that's what I wanted. See? The bearing of M from L. That's on the diagram. So by calculation, I want to show some calculation and just one mark for it there. So you don't expect a lot of work. Simply 210 minus 82.8 degrees, and we get the 127 degrees bearing. We don't put on the 0.2, 127 degrees, and that's what we have on the diagram. The thing is the one. It says now, calculate the value of angle NLP. That's the angle between the lines NL and LP. So it's at the point L, and hence find the bearing of L from P. So now they're gonna want bearing from P to L. But they're telling us that we need this angle inside this first, alright? Let's go and find that angle. NLP. NLP. So let's call that angle something else. Let's put it on in, let's leave it in blue. NLP. That's here. NLP. Right? The N is up here, the L is here, and the P is here. So that angle that I want right now, maybe I got a different color. Let's just do angle NLP. It's inside this, so I don't want to know. NLP. NLP. That's this angle I want. That's just smart. Let's call it something. So we can reference it. This angle is NLP. Let's call it phi beta. Right? Now we're gonna find that angle. Because we have this red angle here. It's 210. And total angle around the point will be 360. And the remaining angle here to complete the 360 must be 360 minus 210. Right? 360 minus 210, that's 150. So that blue angle here now is 150 degrees. Let's put the calculation up here. So the beta up here that I want is 360 minus 210. And so that is 150 degrees. That's the beta. Alright, so let's do that calculation down here. There's two things they ask us for down here. So firstly, they ask for this angle, which we call beta. Angle NLP, which of course is beta in the diagram, becomes 360 minus 210, which is 150 degrees. And it's beta. Alright, and then now the bearing from P up to L. Let's mark that on the diagram. P up to L. Let's call it theta. Let's call the bearing angle here theta, right? I'll call it theta. The bearing of L from P to L. So P back up to L. So now we want the bearing going the opposite way up here. We want the bearing up this way, P up to L. So I want the bearing of this direction. The bearing is at this from position. So it's kind of easy, guys, because they help us. So the bearing that I want, they will put in an outline down here in red. This is an outline at P. As anxious, you have to turn to the right in order to look up at L. And this is that one, which we are calling theta. That's an outline. What happens here? Why did they ask us to find this first? Because these two angles are co-interior. See, they appear to be angles in this U. Put on the U in purple for you. But you have this parallel line, and this parallel line. Those two knot lines are parallel, and they are joined at the base with this one. So that appear to be like angles in a U. They are co-interior angles. So these two angles add up to 180 degrees. Right? So it means then, since we know the beta, we can find the theta. 180 minus the beta. Alright? So that's what theta is going to be. Theta, Mr. Shaw. The theta that we want inside here is going to be 180 degrees minus the beta, which is 180 degrees minus 150 degrees, which is 30 degrees. But because it's bearings, I've put a 0 in front of it. Because theta is a bearing angle. That one. The angle is 30, but the bearing is 0, 30 degrees. So can I give them this calculation? I'll just copy this down. So it is. Right here. Where's it? Oh, so we did the first part for the 150 already. I'm doing the second part now. So we're calling it theta. See it here? So we're calling it theta where you saw. So see, so we know that it is theta. When we call the theta down here now, 0, 0, 0, 3, 0. We know that that is the answer. That is it. We stand done. But okay with that? But good? Let's check in before we move on to another one.
Yes, sir.
When I send the video, it will be good if you go and do the questions over again. Watch the video and do the question. All these papers are in the group, you know? So you can search a group for them. I've given you all these papers before, so they're all in the group. Let's look at 2022. Let's look at 2022. Again, we're looking to do number. Let's see what they said. Alright, here's another bearings question. We're doing some good practice today on bearings. We still have to do elevation practice. Most times this is that bearings question in section 2. Alright, let's look at this one now. It says from port L, so port L here, ship R from port L. This is ship R now. Ship R is 250 kilometers away and it's on a bearing of 065 degrees. 065 is the direction from L to R given as an angle from the north line, clockwise. So that 065 degrees that they gave us here as the bearing is at the front position, the face north first, is the angle you have to turn to the right in order to go in that direction. 065 degrees. So it means that this angle is 65 degrees. Let's put it down. This angle is therefore 65 degrees right here. I'll also put this here, you know, the angle is 65 degrees, but the bearing is 065 degrees. That's what we know so far. It says ship T, that's another ship, is 180 kilometers from L. See it here? That's this one now. And that one is on a bearing of 148 degrees. So again, if we back to the diagram, talking about this direction is on a bearing of 148 degrees. So again, from this north direction, you have to turn 148 degrees to the right to face T, or to go down in direction to T. So that angle there is 148 degrees. Alright, but let's put that a little bit neater. Alright, so I'm gonna add it over here. So this angle over here now is 148 degrees, the outer one. Maybe we shall put a different color. Let's use a different color for that one. So we can use a color, differentiate. So the blue one is 65. This one is 148 degrees. Because you know those two angles, right? You can work out this piece in here. Because everything down here is 148 and now angle up here is 65, so in between here is the difference. Let's put that angle here in red. So inside here we're gonna put the difference. Alright, so that's 148 minus 65. 148 minus 65. Give me 3. Oh, that no, that is 8, right? That's 83 degrees. 83 degrees. So this angle is 83 degrees. Very good at that. But you can understand that calculation?
Yes, sir.
Alright. I know that we have that angle inside the triangle, we're good to go. Because we now have two sides and angle between them. We can use cosine rule and find the length of this side over here, which I know that we're gonna need. Right? I'm more certain gonna ask about that next. Alright. So it says copy the diagram above and insert the value of angle RLT. That's what we just did now. RLT is 83 degrees. That's what we just did. And it said insert it. Alright. But let's show how we get the calculation over here. It is 140 degrees. Angle RLT is 148 degrees minus 65 degrees, which works out to be that 83 degrees is seen on the diagram. And it says now calculate RT, the distance between the two ships at this length. That's cosine rule we're going to use for that. Alright, cosine rule. So let's do it. Cosine rule. It's going to be this side square, which is RT squared, equals this side square plus this side square. That's 180 and 250. 180 squared and 250 squared. Then subtract the product of the two of them, or plus the product of the two of them, minus 2 times 180 times 250 times the cosine of the angle between them. Angle between them is this angle here that we just found, 83 degrees. And again, instead of putting the square on this, and cross the square and square root over everything over here. Put this in the calculator and we'll get RT. Let's work it out with the calculator. So it's gonna be square root of 180 squared plus 250 squared minus 2 times 180 times 250 times the cosine of 83 degrees. That's 289. 289.7. Let's just call it 290 and done, right? With 3 digits, 3 significant figures anyway. That's 290. That's 290 kilometers. That distance. The next part now wants the bearing of T from R. So again, you have to focus on the from position. So it's from R to T. From R to T. Let's put on the diagram. Let's call it theta and reference on the diagram. I'm going to call this angle theta. Alright, theta. Alright, let's see now. From R to T, R to T, R down to T. I'll put that angle in the diagram. Now, as I told you, a question like this, if you want to find this angle, 90% of the time, or 99% of the time, the angle inside the triangle here will play a part in the calculation. That angle will play a part in the calculation, 90% of the time. Don't absolutely have to all the time, but 90% of the time it will play a part in the calculation. Alright? So let's see how we're going to find this bearing angle. So the bearing angle really now, you see from R to T, right? Yeah. Want the bearing up at this from position. Let me draw in the bearing angle that I want for you now. So you can see the angle and then determine how you work it out. You're looking for your Z angles and your U angles. So I'm going to put a north line here in red. But this line is parallel to this line, right? Two north lines. And the angle that I want is this one over here. That's the angle that I want, that I'm calling theta. Now, how can we get that angle now? Multiple ways. Bam, bam, bam. Alright, so I find this angle inside here, alpha, which I can find using sine rule because I can work in this triangle. Now remember, this side we worked out a while ago. Let's put on the diagram. So that's how we go to put what we work out on the diagram. We just worked out this side as 290. So this side is 290 kilometers. So because you have this angle and side opposite each other, you can use sine rule. So you can use this side to find that angle opposite each other in sine rule. So we can find the alpha using sine rule. Alright? So 90% of the time that angle will be a part of the calculation. But this is theta that we want. So to get that theta, another angle that will help us is this angle over here. Then we could use total angle around a point is 360 degrees. Alright? So the question is, what is this angle? Well, this angle is the angle in this U. The U there. This part of the U is 65 degrees. I need to find this other angle in the U. Alright, so this angle over here that we want becomes 180 minus the 65. 180 minus 65. Alright, so that's 115. So this angle inside is 115 degrees. Or is it 105 degrees? Because these two angles are co-interior angles. The angles in the base of the U formed by this parallel line, and this line joining them forms a U or U. Angles in the base of the U are 180 degrees. So it is 180 degrees minus the 65 degrees. That is giving us that 115. And then we're going to use total angle around the point. We need to find this angle, alpha, using the sine rule. Alright, and we can work it out here, right here. And let's do it right here. So I'm going to go sine rule. I took out the 190, this was a 290, right? Let's work out the alpha in, let's work it out in blue, right here. So I'm going to say sine rule for alpha. Start with what you want. So I'm going to say sine of alpha over the side opposite. The side opposite the alpha is a 180. Equals sine of the angle that you know, which is this 83, over the side opposite the 83, which is the 290. To find the alpha, we're going to multiply the 180 first, and then take the inverse sine of that. So the alpha is going to be this. Sine to the minus 1. 180 gone up there, so 180 and the sine of 83 degrees divided by the 290. That's going to give us the alpha. Just going to write down here. Hold on a second, guys. Hello? Hello? What's up? What's up? Yeah, man, I'm doing a class. What's up? I'm doing a class. Yeah, man, I'm here doing a class online. I'll call when I finish. Alright, cool. I need to times the sine of 83 divided by 290. I'll get 38 degrees for the alpha. 38 degrees. So this angle inside here now is 38 degrees. It means then that this bearing angle theta that I want becomes 360 minus the 38 and minus the 115. Because the total angle in here now is the 38 minus the 115. And the total angle around the point is 360. So the red theta angle that we have, that we want for the bearing, becomes 360 minus the sum of those two. Right? So that's what we're going to do. Let's put it back to the one. So this angle theta comes 360 minus the 115 and the 38. And that gives us the theta bearing angle that we want. So it's not 36, 360 degrees. It says 360 minus the 115 and minus the 38, 207. And that's the calculation. I just did all the calculation on this page that I wanted over here. Right, so we have calculated everything here that we wanted for that. I'm going to copy it down. So I want to sign for the alpha first. Comes first. And then you would have said that angle, that bearing angle is a theta. And that is it. So this is the answer right here. 207. Everybody okay with that one?
Yes, sir.
Alright. See, not bad, right? Not bad at all. Alright. How much we got so far? 4? Right, let me do one more. I know we started late. And I don't like the Saturday session to be too lengthy anyway. Alright, so this is the one now. Let me do one more. 2021. And then we'll just call it a day. Alright, and you get the chance to practice these. This comes on practice, guys. You have to practice. And not practice with me. I watch me do it. You have to practice them. You have to do them on your own. So the same question that we did. This is almost on every exam paper. This bearings thing, right? And this is what I said on 2021. We still have some elevation questions to practice. There are some nice ones. So we'll have to make time for that. Make time for that. Alright. Let's see. Alright, there's one. Well, let's do this one and then call it a day. Let's see this one in the 3D. I don't know what to do in the 3D once it. Alright, yes. We're gonna finish with this one. That's ask for how far south R is from H. Alright, let's finish with this one today, alright? This one says, from a harbor H, this is a harbor H, the bearing of two ships, Q and R, are 69, 069, and 151 respectively. They show the 069, but they didn't show the 151. The 151 is from the north line at H, and you turn all the way around here. That is what the 151 is. That angle is the bearing. And so to get the angle inside here, we're going to subtract those two angles. Alright, that's what it is. It says Q is 75 kilometers from H. So this distance is 75. So they're not putting everything for you. So we can put on the diagram. So this distance up here, put on in blue, is 175 kilometers. So this one is 175. That's this length. Right? And if I were to put in the bearing in red that they gave us, this bearing that they gave us, around to here, that bearing angle they said was 151. 151 degrees. I'm using colors. So we can work out the angle inside here in blue. Going to be 151 minus 69. Alright, so the angle is 151 minus 69 degrees. So the bearing is 069, the angle is 69. Alright, so when you're expressing it as a bearing, you have to put the 0 in front. When you're just expressing it as an angle, you don't need to put the 69 in front. Here I'm just expressing it as an angle. Alright, so it's 151 minus 69, that's 82 degrees. 82 degrees. So I leave this on the paper and I write 82 inside there. The exam is where I get 82 from, right? So this is 82 degrees inside here. Alright, so what we have two sides and an angle between. So then we can use cosine rule to find this side over here. Because I told you guys in the class 6, it always forces you to use a cosine rule first. Because if you start a question and you can do the sine rule, use the sine rule when you start a question, then you can do everything with the sine rule that you want. You don't need to use the cosine rule. Right? And if you use the cosine rule one time on a question on the same triangle, they don't need to use the cosine rule again after that. Sine rule will suffice, because then you will have an angle and a side opposite to each other that you know. And once you have that, you can always use the sine rule. So to force students use both sine rule and cosine rule in a question, they tend to set it away that you have to use the cosine rule first. Alright, so that is it. So it's a complete diagram to show the information. So that's what we have done. We have put on this distance that was missing, put in this angle, put in the bearing angle that they gave us. So now we have put on everything on the diagram that they asked for. Then it says calculate the distance QR, which is this distance. So we use cosine rule for that, as we said. So it's the same thing all the time. Told in class that these questions are practically the same with different angles and distances. Now you're seeing it for yourself. So cosine rule we're using. And it's QR squared equals, start like Pythagoras theorem. It's 175 squared and the 247 squared, 242 squared. 175 squared plus 242 squared. And you subtract a piece. You subtract 2 times 175 times 242. And you cosine the angle between them. And the angle between them is 82 degrees. And again, instead of putting a square here, we can instead take off the square and square with this side. So that we square with both sides. And so QR is just whatever that works out to be. In kilometers. So let's get the calculator and work this one out again. So you see, we're basically doing the same things repeatedly, guys. This one I want a little extra on it, but for the most part, you're doing the same thing every question. So the square root of 175 squared plus 242 squared minus 2 times 175 times 242 times the cosine of the 82 degrees. And that's 278. And look here, when the question says to the nearest kilometer, means that they don't put a decimal, no point nothing. Just put the correct it to the nearest whole number. In this case, it's 278 kilometers. So that's 278 kilometers. Put it on the diagram and find, because it helps you to see what you need to do next. So put the 278 up here. 278 kilometers. That's what this size is equal to. 278. Then now it wants a bearing, right? Oh, it says calculate. See if it's want a bearing. Alright, don't want in the bearing. This one don't want in the bearing. Alright, this one don't want in the angle. That's what it says. It says calculate how far due south ship R is off. You see the word off in these things, it means from. Off means from. This just as I said, due means towards. So due means towards, off means from. Alright, so calculate how far due south or how far towards the south R is from H. So from H to R, how far south you're going. It's a distance to what? How far is a distance, not an angle. Alright, so what are they talking about? Look what they're talking about. Down to here, how far south you have to go. Put on purple for you. This is how far south you have to go. This. It's an arc line. Alright, and you put in the east-west line here, and then the distance that I want is this. That is the distance that I want. If I wanted how far east R is from east, then they would want this distance. In this question, I want this distance. Now, when you put in your north-south line and your east-west line, they meet at the right angle. So that's a right angle triangle right now. It's a right angle triangle. And you know the hypotenuse. And we can find this angle inside here. Let's put it down. This angle inside here, we can work it out. This one. Why is it that we can work out that angle? Because remember now, total angle on a straight line over here is 180. And the majority of it, which is 151. So the remaining angle inside here is 180 minus 151. Right? 180 minus 151. That's 29 degrees. Let's show the calculation over here for the examiner where it comes from. So 180 minus 151 is how we're gonna get the 29 degrees I want to put inside here now. I want to use that 29 degrees in this right angle triangle to find this side. And let's call that distance D or X. That's how far south it is. So I'm going to write the D on this stone. So how far south is it? I'm going to write this is actually D on my diagram. I'm going to work out the D. Because that's a right angle triangle I'm working in now, I'm going to use so-called tower. What it is, I know the hypotenuse, because the hypotenuse now here is 242. And to this angle, it is adjacent that I want. If I ask for how far east, it will be this side we'll be using. And it will be the opposite. So we'll use sine trig ratio. Sine equals opposite of hypotenuse if we wanted this. For this one, however, that we want to use cos equals adjacent over hypotenuse. So it's going to be, I'm going to show the calculation here beside the triangle. It's going to be that the cos of 29 degrees is the adjacent side that we want, D, over the hypotenuse, which is 242. So to the D as a subject, the 242 are multiplied across here. So the D is going to be 242 and the cosine of 29 degrees. Let's work it out over here. 242 times the cosine of 29. And so that's 212. So D equals 212, and that's kilometers. And this is the calculation that we want. That is it. That is it. That is it. It's question done. Question done. Sit down. Question done. Alright guys, so we're gonna end it there for today. All these papers that I did 2024, 2023, 2022, 2021. 4 questions a day. 24, 23, 22, 21. 4 recent exam papers. And see that basically they're all asking practically this, asking you to do the same thing. in a sense. To get the answer that they ask you for, you're basically doing the same thing mainly. Just this one today was a little bit different, this one. And I told you in the class that sometimes they ask those things. Now you see for yourself. Alright, so I'm gonna end it there, guys, and you go and practice. We do the questions that we did today as first order of business. Alright, and we'll take it from there. So tomorrow we're gonna look at some 3 dimensions trigonometry. I don't know. I might decide overnight to just do some more practice of this level work in the class before I do the 3D trigonometry. But a lot of persons not coming to the Saturday classes first to practice. So we see it now. I'll decide overnight what we do. Alright guys, but see you in class tomorrow morning. Bye everybody.